Welcome to today's Hackerearth webinar on how to become a data scientist. I'm very excited about this, and I hope all of you are as well. And let me introduce myself briefly. I'm Jesse Steinweg-Woods, and here's a quick bio about myself. I did my PhD in atmospheric science from Texas A&M, and I focused my research on numerical weather and climate prediction. And previously, and I actually just completed my job at Argo Group Insurance. I was a data scientist starting in November of 2015, and I was working on things such as pricing models using machine learning techniques, which is something that's pretty new to the insurance industry. And my new job, which I will be starting Monday in the United States, I will be a senior data scientist at tronc, which means Tribune Online Content. And these are some of the newspapers in the United States, such as the Los Angeles Times, and the Chicago Tribune, the Baltimore Sun, the Orlando Sentinel, and a variety of other papers, but more focused on the digital side of the newspaper, the online portion. And I don't know exactly what I'll be doing yet. My understanding is that I will be working on developing a new recommender system for all of the newspaper websites that we have, along with understanding our customers better. So let's get started. One thing that I want to discuss first is, I assume all of you are interested in possibly becoming a data scientist, so I want to discuss why is now probably a good time. I don't know if you're familiar with Glassdoor, but the United States. Glassdoor is a website that keeps track of a lot of job statistics and posts information about interviews with companies, salary information, a lot of great data that they collect. And one of the things they do is they take all this data and do surveys about work satisfaction, the amount of jobs available, the salary, the potential for an increase in the potential jobs you could take, and work-life balance and other aspects, and kind of combines it all together into a single score, and they come out with their list of the best jobs. And in 2016, data scientist was the #1 job they had. And yet again, this year, Glassdoor just released this last month, data scientist was again the #1 job 2 years in a row. So it's got a pretty good track record so far. If we look at this Indeed graph of job trends for data scientists, you can see that it's definitely on the upswing. I learned what data science was back in October of 2013, so you can see here. At this point, I heard it for the first time. I really didn't know what it was before that. But the minute I found out what it was, I did some thinking and some research, and I found out that was an actual job that I could do, and I thought that was a really good idea for me and a great fit. So as you can see, since then it's been going up, 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 and especially in 2016 there's been a big spike recently. So the demand is here. It's a job that allows you to have good work-life balance, it has good compensation, and it gives you the opportunity to work in a very large variety of industries. So it's got a lot going for it. Now, in terms of training to be a data scientist, here's a funny meme I found about data scientists that I think is pretty humorous, and I think actually has a lot of truth to it, which I will be explaining. Data science is a lot of different things to a lot of different people, and that makes it very difficult to understand, not only from the side of the person doing the job, but also from the side of the companies that are hiring for these people. And there's a lot of information out there about how is best to train to be a data scientist. Because there's been a lack of cohesive definition regarding what the job entails, I think there's been a lot of confusion out there. And so I'm going to try to clear things up, at least from my perspective, in the path that I've gone through as a data scientist. So one question that is raised very often, I'm found, is the question, do you need a PhD? And usually what I found happens, and this isn't always the case, is that data scientists that don't have one, if you ask them this question, they immediately say, you don't need one. Data scientists with a PhD like myself, I'm more nuanced on it. I wouldn't say necessarily you don't need one. I would say it depends. And that may not be a satisfying answer to people. But let's just take a look at the statistics. There's this great study done by this recruiting firm, Birchworks, which happens to be in Evanston, Illinois, and it was actually just down the street from where I used to live. I've actually been to Birchworks myself, and they have a lot of great people. They do really good work, and they came out with this great study, which I have a link to here, for last year, and they surveyed all these data scientists regarding their education levels. And as you can see here, a plurality of data scientists actually do have a PhD. And a very significant portion have at least a master's degree. Only 8% have a bachelor's degree. And I've looked at several different profiles of data scientists that I know, and data scientists on LinkedIn and a variety of job markets, and this seems to match my understanding of the field as well. So if you want to be a data scientist, at least in the United States, having a graduate degree is pretty important. Now, I'm not saying that it is impossible to be a data scientist with just a bachelor's degree. There are some amazing data scientists that have just a bachelor's degree. That may be enough. But for most people, getting a graduate degree is going to be an important signal to employers. So the PhD, I think, can make it easier for you to get your foot in the door because employers kind of know you've already been tested. You know how to, depending on your background, of course, but a PhD signifies you know how to work on really tough problems with great intensity. And a great thing about a PhD is that it teaches you how to learn things very quickly, which you're going to be needing to do a lot as a data scientist. I think that's why employers value PhDs for this reason. But that's not to say you cannot pick up the skills you need to be a data scientist if you don't have one. You can. But you need to know what those skills are, and the bar for entry as a data scientist is going to be a little bit higher for you because you don't have that PhD, so they might need to test you a little bit more stringently than they would a PhD because the PhD, they can make more assumptions about you. The other thing I've noticed is that if you want to eventually be in a leadership position, I think it is easier to get there if you have a PhD than it is with a master's degree. That's not to say it can't happen. It can definitely happen, but it will make it easier for you to do this. Here are, as part of the study, again, some of the popular data science backgrounds that they've found data scientists have. They come from a wide variety of fields. And you can see the most popular one being mathematics and statistics, which makes a lot of sense given the conventional wisdom of data science. But we also have people that come from engineering, computer science, of course. I'd say that data science is kind of a hybrid between computer science and mathematics and statistics. The natural science portion, which is where I come from, given my PhD in atmospheric science, is the fourth largest cohort in this study. And then you have, there's a bit of a gap, and then you start to have people from social science, economics, business, operations research, and even some people from medical science, but this is less common. And I've put a little logo next to each of these fields. There are two very popular programming languages in data science, Python and R. And I found from at least my personal experience and talking with other data scientists that people from these different backgrounds tend to have more of an affinity with one of these two programming languages. So statisticians, obviously, R is big for them. But in engineering, computer science, and natural sciences, Python is more popular. In social science and economics as well, they more tend to be R, coming from an R background. Now, I mean, there are exceptions, of course, but this just seems to be what I've noticed most of the time. So, if I were to give you the basics of what I think you should learn to become a data scientist, number one thing I would say is pick an open source, and I put it in blue for a reason, open source language, well designed for data science. So right now you basically only have two options, Python or R. Python is what I personally would recommend if you are not familiar with any of these languages. R can also work if you already know it well. I'm not saying you should just drop R and just learn Python from scratch. If you already know R well, fine, build on that, become very familiar with the most popular libraries that data scientists tend to use in R. But if you are starting, again, from scratch, not knowing anything, I would go the Python route. I think that it's going to show a little bit more future potential for a variety of reasons. I know that's a controversial topic. That's just my opinion, based on trends, for example, in how machine learning is being applied at companies. You look at job search trends. I did a project myself where I looked at the key job topics that were associated with jobs. So which skill sets are employers looking for most frequently? And Python tends to win out over R a little bit. One caveat I will also say, you'll notice I have SAS and MATLAB with the giant cross through them. I do not recommend using these languages. And the reason I say that is because they are not open source, they cost money, and they cost a lot of money. And that can limit where you are going to be able to find a job. So startups, for example, are strapped for cash, and they need to get results quickly. They're not going to have the money to be using something like SAS or MATLAB because they require expensive licenses. The other disadvantage of open source, or of these closed source tools that you have to pay money for, is there's going to be less documentation available on how to use them. So with open source tools like Python and R, it's very easy to find answers to your questions on sites such as Stack Overflow. But since SAS is completely controlled by the company in North Carolina that writes the software for it, the only way you're really going to get help is from the user manual or people that know SAS, and that's it. It's very difficult, comparatively, to Python and R to find help. And you're also going to run into flexibility problems. The only tools you're going to be able to use, for the most part, with SAS and MATLAB are SAS and MATLAB tools. But because Python and R are very open, you can see the code, you can make changes to the code, it's much more flexible, and flexibility is very, very important in data science because what you need to use can vary a lot from project to project, from company to company. So stick with these two. And Python, if you don't know R yet, go with Python. This survey from Birchworks, again, kind of proves this out. If you look at the difference between what they call predictive analytics professionals on the right and the data scientists on the left, you can see there's a big difference in the drop-off of SAS usage. For predictive analytics professionals, which I would say are more like data analysts, it's 43%, but for data scientists, it drops all the way down to 3%. So you can see there's a huge difference in how the tool is being used. Python is only 16% for predictive analytics professional, but for data scientists, it jumps all the way up to 53%. So given this information, I think it behooves you to choose an open source tool like Python or R and stay away from expensive closed source tools like SAS and MATLAB. The other great advantage of using an open source tool like Python or R is that they're free. So if you need to practice, or if you want to understand how the code works better, you can download it yourself and it doesn't cost you a dime. And that's a great advantage, especially if you're trying to learn how to be a data scientist. So because I prefer Python, and I think it's the better tool in the long run right now, these are some of the common libraries used in what I call the Python data stack. And I would suggest learning these libraries very well. So Pandas, for example, is a great library for manipulating data. It has data in a similar format to R called data frames, and is going to be your workhorse. You'll use quite a bit. I would get familiar with it. It's one of the most well-designed libraries I've ever seen. It's amazing. I highly recommend it. And these two, NumPy and SciPy, form a lot of the backbone for a lot of these other libraries in terms of calculating matrices very fast and efficiently, dealing with optimization problems, dealing with anything that requires a lot of fast computing of numbers and matrices. These two will underlie a lot of that. And so it's kind of good to know how they work and where they're coming from because they form the basis for a lot of these other tools. Matplotlib is used for visualization. There are other tools that are built on Matplotlib, such as Seaborn, that can make it a little bit easier to use. This is one of the complaints, that Matplotlib is not user-friendly. I will agree with that. But there are other libraries you can use, like Seaborn, to make it easier to visualize data. IPython allows you to have an interactive environment, so you can type in code and then see what happens and then look at the result, along with Jupyter Notebooks, which are a great way of documenting your work and sharing it with other people. And of course, there's scikit-learn, which is the has quite a few machine learning libraries that are useful for a variety of problems, and the documentation is excellent. So it's a good library to learn well, and it's somewhat easier to learn because the documentation is so good. The other thing is it's very, very important to learn SQL. And this is a skill that is not taught very well in academia. So the only way you're going to learn it is to either get an internship or to study it yourself. Now the good news is SQL is not that hard to learn. It just requires some practice. So the best website I've ever found to practice SQL is this website right here, SQL Zoo. It walks you through how to do a lot of the very common operations you're going to need to do as a data scientist, because interacting with databases is very important. And I can't underemphasize that. If you are going into a job interview and you want to get the job and you have absolutely no SQL experience, you have no idea how to use it, that's going to be a bit of a red flag. And a lot of people that are coming straight from school don't have this experience. So if you haven't practiced this going in, it's going to reduce your chances of getting that job. So make sure you learn it. It's very important. The other thing, of course, being machine learning, which is a very important tool in a data scientist toolbox. So I have 3 sources here that I would recommend. Andrew Ng's Coursera course is very popular. I highly recommend it, although the coding is done in MATLAB. You don't have to use MATLAB, but that's just the way he teaches it. I focus more on how he's presenting the way these algorithms work. It's a great way to get started with machine learning. If you're ready for some really hardcore stuff, this book is very math heavy. It's not meant for beginners. There's an easier version of the book called Introduction to Statistical Learning. It uses the R programming language, but every hardcore data scientist, I think, should have read this book because it goes through all the machine learning algorithms that you're probably going to end up using at some point in great detail, and is the best book I know on the subject. So it's difficult to read, I admit, but if you really want to know this stuff well, it's the book to go to. And of course, the scikit-learn documentation, as I previously mentioned, is very, very good. It's one of the advantages of this library. They have a lot of tutorials that you can look at, that they can walk you through so that you can learn how to process a lot of these models and how the code works in terms of how the objects are organized and how to interact with them, things like pipelines and cross-validation and how to fit models, how to evaluate their performance. All of that is covered in the documentation, and then go through these tutorials. It will help you a lot. Another thing that data scientists often need to know are some, not a ton, but some Bayesian statistics. This, of course, depends on the job. Some jobs are going to require a lot more of it than others. But for most jobs, just the basics are going to be enough to start with. And you don't need to read some very old textbook on Bayesian statistics to really understand enough to wrap your head around it. I recommend these 2 sources. This one is called Bayesian Methods for Hackers by Cameron Davis and Pylon. It's available on GitHub for free. There are interactive code samples you can take a look at along with notebooks. It's a great way to understand, kind of from more of a computer science perspective, how to use Bayesian statistics and how to think about Bayesian statistics and the kind of problems you may end up dealing with. Statistics for Hackers is along the very same lines. It's a great presentation. You can see the slides for this at this link. It was a talk given by Jake Vanderplas, who's a professor at the University of Washington. Highly recommend it. This is a good place to go. The other thing is to know your basic probability distributions and understand them. So there are quite a few, but it's very helpful to know how they are formulated, what they mean, in what kind of situations you need to use them, be aware of them. Cloudera posted this a couple years ago. I think this is a great place to go and just get a basic understanding of these distributions. You're probably going to need to read into them a little bit in more detail, but they're going to be part of your work. So it's important to understand them, because when you're constructing a model, you need to understand how the data was distributed in the first place, because that will affect your modeling strategy going forward. So know these statistical distributions. Now, once you've researched all this stuff and kind of learned these basics, you need to figure out, well, how am I going to get the interview in the first place? How do I prove to people that I've learned anything and that I can do this on the job from day one? Well, the best way to do that and the best way to get better at data science is to do data science. It's one thing to just read about this in a book. It's another thing entirely to actually do it, because you're going to run into problems, you're going to run into hiccups, and you're going to need to learn new things, and you're going to need to change your assumptions and ask new questions, and it's a very iterative process, but it's great, great practice. And Monica Rigatti knows a lot about data science. She was a great data scientist at LinkedIn. She's now an advisor. She answered this question for it. It's the best answer I've ever seen on the subject, so if you want to take a look at it later, I highly recommend it. The link's here. But the too long didn't read is do a project you care about, make it good, and share it. And so I did this myself when I was trying to get a job, because this proves to people that you really care about data scientists, are very passionate about it, because you're willing to do a project on your own time and on your own terms, not just for class. It gives you practice on how to communicate your results to other people. It gives you practice on how to answer your own questions, what questions to ask in the first place. And it's just very, very helpful for this. So here's an example pet project. A few pet projects actually are on my website. There's a link to my website below that I generated myself to help me get a data science job. And these kind of projects should give you a flavor for some project ideas that maybe you could look into, and how to document your results and share them with other people. So this one I did, for example, was about web scraping the job site Indeed for key data science job skills. So I had to figure out how to scrape the web, something I never known how to do before, but is a very helpful tool for data scientists if they need to get access to data that's not available in a database somewhere. And that was a very valuable learning process for me, and I got to document my work and share my results. And actually, when I put this article up on my website, it got 6,500 hits within 24 hours, and Indeed themselves was interested in my post and actually contacted me to schedule an interview. In fact, this was my very first data science interview was with Indeed because of this post. Now, at the time, I didn't know a lot about the data science interview process, so I didn't do very well. But it was a valuable learning experience. So just a tip of mine. Now, about Kaggle. A lot of people think that a good way to practice data science is to do Kaggle competitions. I will say somewhat yes, with a caveat. It's great for practicing machine learning, but that's not all of data science. That's a very small part of data science. There are a lot of things Kaggle misses, such as asking the right questions. Which data sources do you want to use to answer these questions or develop your model? What kind of metrics do you need to optimize for? And all of the work that's involved in making this data set in the first place. Data is not clean and in a nice, tidy format in the real world like it is on Kaggle. You're going to have to do a lot of work to get it into that format in the first place. But the great thing about doing a pet project instead of a Kaggle competition is that they can cover all of these areas. So the thing I would say about Kaggle is I would definitely check it out for some machine learning practice. I think they use a lot of great tools that are very helpful to learn. I've definitely learned a lot from reading Kaggle blogs, understanding how people won competitions, and trying a couple out on my own. I talk about that a little bit on my website if you want more information, but there's too much missing if you just do Kaggle. And I think these pet projects will show your work better. Plus, these Kaggle competitions can be very, very time-consuming. And you may not be able to compete with people that are much more experienced and have all the time in the world to get that last fraction of a percentage point in their competition and end up winning. So it's a bit of a risk. If you become a great Kaggler, you're going to get attention from companies, sure. But it's not as safe of a bet, I think, as working on pet projects. So work on pet projects, I think, is a better way to go. So which jobs should you apply to in the first place? This is very hard, and this has become more hard because companies themselves don't really understand sometimes what data science is. And this great poster from Udacity, I think, kind of explains the problem. So when I look at job postings, I often see jobs that fall into one of these 4 categories. And you can see the skills that are kind of required for the job type. So you need to decide for yourself what kind of job you're actually interested in and which skills you feel kind of match the job best. So this first one, for example, a data scientist is a data analyst who lives in San Francisco. You can see that software engineering isn't as important. Statistics is somewhat important, but the really big thing is data visualization and communication. To me, this is really just a data analyst job. I wouldn't say this is a data scientist job because data analyst jobs tend to focus more on the visualization communication part. That tends to be emphasized more. If you see this kind of position, which is please wrangle our data, that actually is probably more a data engineer role than a data scientist role. Because you can see there's a lot of focus on data munging and there's a lot of focus on software engineering. So they're more focused on building the pipelines. And the thing I will say about this is I've noticed that a lot of startups especially are really, really prone to saying they need a data scientist. But then you ask them, what do you want the data scientist to do? They then say, well, we don't have great data yet, and we need someone to build out the pipelines to get this data and store it in a nice format that's easily accessible and make sure that that process goes smoothly. But that's a data engineer. So they're asking for 2 different things. So if you interview for data science roles at startups especially, make sure they really know what they want. If they don't have the data available yet in a nice format that's going to be reasonable to query and to investigate, they probably don't need a data scientist yet. They need to get the data sorted out first. So just as a warning, we are data, data's us. This is more companies that use data all the time, like Facebook or Netflix or Amazon. This is what I'd say is a type B data scientist. They more focus on building products. I don't agree with this chart that software engineering is not as important. I think it's very important. But that's going to be focused on building user-facing products like the newsfeed or recommender system or something users are going to be interacting with. And the last would be reasonably sized non-data companies who are data-driven. Those are going to be companies that are more hiring type A data scientists. They're trying to answer difficult questions. And so these skill sets are going to be more applicable. I need to move on, but we can talk about this more later if you want to. The other thing is look at the team. Teams tend to like hiring people similar to themselves. And this actually happened with my own team. On my team, we have 3 people, all of which have PhDs, all of which work in either physics or kind of applied physics in my case, or applied math. And we all use Python, all 3 of us. So I'm a good fit for that team. People tend to have a hiring preference for this. So if you notice, I was just looking at the team members. If there aren't any PhDs on the team, they probably aren't looking for someone that has a PhD. If everyone on the team has a PhD, you're probably going to need one. Are they mostly computer scientists? Are they mostly physical scientists? Are they social scientists? Do they seem to prefer Python or a mix? So I would investigate the profiles of these team members you would be potentially working with and get a general sense of whether you kind of fit in with that team. I wish there was a little bit more diversity in hiring sometimes, but this is kind of the way it's worked out. So, I mean, you can get a job if you feel like you don't completely fit in with that team, but it's going to probably be more difficult. One thing that's helpful sometimes is contact the team lead, see if you can figure out on LinkedIn or wherever what their email address is, and just kind of reach out to them and just say what your name is and express your interest. And if you've done these pet projects on your website, make sure you show them this and send them a link. Say, here are my pet projects if you want more information, because that can kind of separate you out from the funnel of online applications where there may be hundreds of people and you need to stand out. So this doesn't always work, but sometimes it helps. Also, go to Meetup events. Meetup is a big thing in the United States. I'm sure there's a similar thing in India where you can network with other data scientists. It can help with job leads. You can learn new things. I'd highly recommend doing this. It kind of gets you out there. A lot of the times, the same people show up over and over and over again. And if you're one of those people, people are going to kind of think you belong. So if they have a new opening that they haven't posted publicly yet, you may get insider information on that before everybody else. And you'll also be learning new things along the way. So I recommend going to these. It helps networking. It helps you learn. Interview a lot. finding a good fit takes a lot of time because all of these roles can be slightly different. All of these companies can be slightly different. What they need you to do can be slightly different. The makeup of the teams can be slightly different. So this is going to take a lot of time. There are some jobs where they just felt like I wasn't a great fit. And there were some jobs where I felt like they weren't a great fit for me. So this is a time-consuming process. It's very difficult to match companies that need data scientists with data scientists that would also fit in there. So until this gets sorted out and becomes an easier process, as data science gets more well-defined, you're going to have to be patient with this, but it will improve your interviewing skills, and it will make you more knowledgeable about what to expect in future interviews. So these are my basic interview tips. These are the questions that I've received at one point or another. There are 5 kind of key questions. There's the take-home machine learning task, where they'll give you a data set, and you have to investigate it in some way, answer a question, develop some kind of machine learning model, and then submit your results back to them. Whiteboard coding, where you kind of have to answer a question on the spot in front of a whiteboard, or these days in front of a collaborative screen where they'll say you need to program this task, and then you have to do it right there, right in front of them. These are going to come up. It's a little bit different than software engineering interviews. I would focus more on data structures and algorithms than anything else. There's going to be whiteboard SQL too sometimes. They're going to want to just check that you can query things with SQL. Those aren't quite as difficult if you've been practicing. Bayes theorem probability questions, these come up sometimes, so just be familiar with Bayes' rule. And understanding how to evaluate models is important. People are going to ask you about this because if you don't know how to do it correctly, you're not going to know if your model is actually working, and that could cause a lot of problems. So look into this and make sure you can answer questions about how to evaluate a model and how well it's performing. So just a few extra tips on these. For the take-home machine learning problems, I would focus on using tree-based methods such as random forests or gradient boosted trees. And the reason I say that is because you're not going to have a lot of time to do these. You're going to need to move pretty quickly. And oftentimes they're timed, so you have maybe a few hours to do it. And sometimes they'll keep track of this. So they'll say, we're going to send this to you at 12 o'clock. You have to have it back to us by 4. You're not going to have a lot of time to test tons of different models and do a ton of data prep. Great thing about tree-based methods is they don't require nearly as much data prep. So I would practice with these and use these in these take-home tests because you're going to get pretty good results and you don't have to do as much preparation up front. For whiteboard coding, as I said, it tends to be similar to software engineering interviews, but focuses most on the data structures and algorithms questions. So these are some sources that you can look at, such as Cracking the Coding Interview book. The websites Interview Cake, Hackerearth, and Project Boiler are also good places to go. Whiteboard SQL, same thing. These are easier if you have used SQL a fair amount. SQL Zoo is a good review, or practice location. You should just go through some practice problems on SQL Zoo. You should be good to go. Bayes theorem. For Bayes theorem problems, all you have to do is memorize this formula and understand what the terms mean. That's really it. There are some sample problems at Glassdoor that are helpful if you want to see what these problems look like. Usually they'll involve what is the chance you actually have cancer, or this is the probability it rains on this day and this day, or if I have a bunch of brown puppies versus white puppies, what's the probability that I'm drawing a white puppy? These kind of questions tend to come up. All you need to solve them is Bayes theorem, and you can solve it. So just study this formula well and practice using it. Machine learning evaluation metrics. This is an example of a rock curve. Understand what that means. Understand how to do cross-validation. Understand there's so many metrics for classification, so you need to understand the difference between when is it good to optimize for accuracy, when is it good to optimize for things such as the area under the curve, precision, recall, F1 score. Understand all these terms and when a model would be best used for those metrics. Now, here's the stuff you probably don't need to worry about yet. A lot of people think you need to know deep learning right off the bat. You don't. Unless you're working for a company that processes a lot of images and sound, where deep learning actually can be very useful. Spark and Hadoop, I know a lot of people love to talk about it. It's a lot of hype, I think. Unfortunately, right now, companies don't yet have the scale necessary for it, with the exception of a few. Recommender systems, which I'll be working on, most companies actually don't need them if you think about it. So you probably just need to be familiar with what they are, but I don't think you need to know how to build one from scratch. There was one company that tested me on it, though, but it's very rare. And advanced natural language processing, I don't think you need to know it at a very detailed level, but you should at least know the basics of it, so that you could work with text data if you needed to and develop a simple model that predicts whether a sentence is positive or negative. And that's really all you're going to need for your first job. That's enough. So to conclude, until we get to the questions, these are what I would say are the alternative facts of data science. Myths that have kind of been pervasive that I, at least in my opinion, I think are just not true. So alternative fact number one, most of data science is fine-tuning models to get the highest performance possible. Now that may be if you're on Kaggle, but reality is the vast majority of the time you're going to spend most of your time cleaning and merging data sets. You're basically like a data janitor a lot. And that's a really important step, because if you're generating a model that's very flawed, or dirty, or too many missing values, the model's not going to work very well. So this step's really, really important. Don't underestimate it. But it's also going to be a lot of your work. So if you don't like merging data sets together, if you don't like querying things a lot, if you don't like fixing it, to me it's kind of like taking a block of clay and sculpting it. If that's not something you would enjoy doing, data science probably isn't for you. But the rewards that you get after doing all of that work are totally worth it in the end. So if you can get through the data janitor type stuff, you will enjoy this job. Number two, big data is everywhere. You will need Hadoop and Spark all the time to solve every problem. Well, I just read a report that was issued less than a week ago that said Hadoop's popularity is starting to fade a bit because companies are starting to realize they don't really need it. With exceptions, most problems can actually be handled on a single machine. So I think companies they saw Hadoop and Spark as shiny tools, and they thought, oh my gosh, we really need this. But then the reality is they don't have that much data actually they need to process. This may change over time, but I'm saying right now that you're probably not going to need to use Hadoop and Spark for problems that you would be dealing with as a starting data scientist at most companies. Not all companies. There are definitely exceptions to this rule. Number three, deep learning solves everything. Other methods are just obsolete. There's no point using anything else. The reality, though, is you actually probably don't need it unless you are working with images and you want to maximize performance. So if you want to take a bunch of images, you need to classify what they are. So if you're working at a clothing company, for example, you want to say, I want the computer to automatically know that this is a red dress of this brand or something like that. Yes, deep learning is going to be very, very useful for you. But if you're working on problems like a churn model, or if you're working on just trying to understand how customers interact with a certain kind of data that has nothing to do with images, a variety of other data science problems, especially if you need something that's really fast and scalable, deep learning is not going to be your solution. So you can probably avoid learning too much about deep learning for the moment. So that's my presentation. I want to get to the audience questions that were asked before I started and try to answer them quickly, and then I'll leave the remaining time for other questions. So the first question is, how can a college fresher, say, studying in sophomore or final year, become a data scientist? What projects can they do? What skills should they focus on? And how to start applying for jobs? Well, I pretty much discussed this already in the presentation. I would say one thing I would add, though, is get an internship. I think that's really, really important. I can't emphasize that enough. So during your sophomore, junior, and senior years, maybe even after your freshman year, try to find data science internships or data analyst internships. Work experience is really, really important. So I would go to job fairs and talk to companies and see if they have anything available. If you can be flexible and move to another location for a summer, that would be even better, because it's going to increase your chance of being able to do a data science internship. So by the time you get out, if you have all this internship experience you've been doing every summer, it will make finding a job much easier. The next question, how can an experienced professional make a career shift into data science? So for example, someone has 3 years of experience in Java and they now want to become one, or someone who knows Hive, Pig, Flume, Hadoop. So it sounds like this person is more coming from either a software engineering background or a data engineer background. I would say it's great that you have the programming experience, but you're going to have to learn a lot about machine learning and statistics because you probably aren't as well versed with that. So I would focus more on those aspects of it. So going to Kaggle is a good start. Understanding all the statistics regarding underlying distributions is a good start. You have a lot of the skill sets already, but you just need to fill in those missing gaps with the math and statistics and machine learning and maybe some data visualization as well, and also understanding how to approach problems, and communication also being a really big one. Communication is something I underestimated the importance of a bit when I was starting out as a data scientist, and now that I've been one for a little while, it's really, really important. You have to talk to a lot of different stakeholders. You're probably going to have to do that more as a data scientist than you would as a software engineer or as a data engineer. So you need to get better at understanding the business from the business people, understanding the product very well. These kind of things are going to make a transition easier for you. How is a machine learning engineer different from a data scientist? I would say the difference is it's a little difficult to say because data scientist is such a catch-all term. It's basically a hybrid of statistics and computer science and mathematics. And machine learning engineer can definitely fall into that. But I think machine learning engineers are most focused on getting stuff into production, and they're less focused on answering questions that the business has. So they don't do as much exploratory data analysis. They don't look at sales metrics as much. They're more focused on getting things into production that people are going to use on the other side, such as recommender systems, or something that categorizes images for users, that sort of thing. So that can give you a bit of the taste of the difference. How is a statistician different from a data scientist? This is a very difficult question. There's actually a lot of debate about this, and I actually had to research it before we started. What I come to the conclusion of is that statisticians tend to have less programming experience, so they're more focused on inference, drawing conclusions, understanding uncertainty, confidence intervals, that kind of thing. Whereas in data science, you're more focused on making a prediction and making a product that will automatically do this. So the focus is a bit different between the two. Statistics is more focused on inference, and machine learning is more focused on prediction. So that kind of says the difference, but it's a very debatable subject. I'm sure people could talk about for hours, but that's my take on it based on what I've researched. How is a data engineer different from a data scientist? The easiest way for me to explain this is that the data engineer is kind of like a plumber. They're the ones that build the pipes. So let's say you're building a fountain, for example. You need someone that gets the pipes to take the water from where the original water source all the way up to the fountain. The data scientist takes it from there. They deal with how the water is going to come out of the fountain. What shape is the fountain going to look like? Is it going to squirt in regular intervals? Or is it going to have a nice pulsating effect? Something along those lines. That's the best analogy I can come up with. So the data engineer focuses on the backbone architecture of the data, how it's being processed, how it's being funneled, especially for complicated data pipelines or things involving streaming data. The data engineer takes care of that. The data scientist then does something interesting with the data, like visualization, generates a model, generates a new kind of product, recommender system, whatever. But that would not be possible without the data engineer's help. So my new team actually does have a data engineer that we can talk to all the time, understand the data better, get the data that we need to be able to do our work. What is the relationship between data science and machine learning? Machine learning, I'd say, is a very important tool in a data scientist's toolbox, but it's not the only one. A lot of data science jobs are going to focus on predicting things, but some data science jobs are going to focus more on inference. It just depends on your personal definition of data science and what the job is that you've been asked to do. So I'd say it's an important part of data science, but it's not the whole part of data science. What are the most commonly used machine learning algorithms in industry today so that students can master them first? Well, Kaggle's kind of a good place to understand this because the algorithms tend to change over time. So a few years ago, the most popular algorithm tended to be random forests. And then XGBoost came out, and it moved on to gradient-boosted trees. And then there have been some computational advances in how to apply deep learning. So now deep learning is becoming more popular. That's kind of a way to get an idea of where things are going. The truth, though, is it really depends on the problem. I wouldn't focus so much on which algorithm to use as I would on understanding the questions first that you're trying to answer. You could focus on the model later, because it's easier to test a bunch of different models and see how they perform, and then just go with the best one for your needs. Like in some cases, for example, if you have hundreds of thousands of features, it may not be computationally feasible to do something like deep learning or gradient boosted trees. You may be limited to linear solutions like logistic regression or support vector machine with a linear kernel because it's very quick. Other algorithms are just going to be too computationally expensive. So it just depends on the problem that you're having to deal with. What is the future of the data scientist's job? Will it survive after 5 to 10 years, or will it get automated? This has been a controversial question. I think it depends on what you are doing as a data scientist. So if you're doing very basic data polls that are dealing with not very complicated queries, and essentially you're just doing business reporting, that probably is more likely to get automated. But I think if you are having to really analyze a company's problems and design a machine learning model or some other product that is tailored specifically to that customer or company's needs, that's going to be very difficult to automate because there's so many things you have to consider when designing a possible solution to a problem. So I think the more you're focused on developing machine learning models that solve difficult problems and new products, unless you're focused on just basic data visualization of summary reports, the less likely it is your job's going to be automated. Can data science be used in building geological applications? If yes, what would be the starting point? I'm not going to be the person to answer this question because I don't have a background in geology. I know that Kaggle tried doing some consulting work with oil companies, but then the price of oil fell like a rock, and Kaggle stopped doing that. So I know that some people were doing things like monitoring the flows of oil pumps to detect problems with the underlying machinery sometimes, or you can get an idea based on geological characteristics of a well site, whether it's more likely to have more oil or not based on past data. So again, I'm not a good person to answer this question, unfortunately, but that's my best understanding of it. So good luck. Here's my contact information. Here's my Twitter account. Here's my email if you want to reach out to me with questions, and also my website. I highly recommend you go there because I have all the pet projects I've done you can take a look at. I also have a lot of book reviews, so if you want to know some good books to read for data science, you can go there and see them. I have several books there, and it tells you the rough difficulty level of the book and what I found helpful about it. So that's a great place to go. I also have links to websites that you might find useful that have good information. So all of that's going to be included on my website, and also my contact information is there too. So I'd highly recommend you go to my website if you have further questions and you want to learn more information. So that is my presentation. Now I'd like to see if we have some questions. So I'm looking to Vishal, see if we have any questions here that want to be asked, because at the moment I don't have access to the questions panel. So just hold on a minute. Let me see if we have any questions. Okay, well, he's telling me that I should have access, but I'm clicking on it and it's not working. I apologize, everyone. Okay, he's going to go ahead and type and send them to me on my phone. Okay, how is data science different from data analytics is a question that was asked. I think data analytics is more focused on looking at data in its present form. So I call that maybe descriptive analytics. Whereas data science, I think, is more focused on predicting the future. Data analytics is kind of like the present, the past, and data science goes into the future, trying to predict what will happen in the future. So that's more predictive analytics and prescriptive analytics. And prescriptive analytics is the most automated form of analytics where you are suggesting an action that a company should actually take, given the information that the model presents. Another question we have, I'm working as a PL SQL developer in a firm which provides lending solutions to banks, automobile finance companies for about a year. I've joined machine learning specialization on Coursera, organized at the University of Washington. I want to know what else I require to gain knowledge in the field of data science. Do all these MOOC certificates help in getting an interview call from the companies which are working in the field of data science? The thing with the MOOC certificates is that a lot of people are taking them, and they don't really prove that you actually know how to apply them. So I would say that what I would recommend you do is kind of follow the tips I gave in this talk and start developing your own pet projects that you can share online with employers, that they have some evidence that not only have you taken these courses, but you understood them and you can do things with the knowledge that you were given in these courses. I think that will go a much longer way towards being able to get an interview. Because right now, it's just too competitive. There's so many people that have taken these courses. Will IBM Watson replace data scientists in the future, or will any AI advancements replace data scientists? So here's the thing about IBM Watson. I love IBM, but I think I don't really understand what IBM's trying to do with Watson. I think Watson is more designed for companies that don't have a data scientist at all, and they just need a tool that they can use that's more user-friendly. But there are going to be a lot of limitations to what that tool can do. So if you need to generate a very basic model that answers a very basic question, can Watson do that? Yes. There's probably more it can do. I'm not very familiar with the tool. But because it's a tool that's designed for that purpose, it's going to run into issues when you need a customized solution that's appropriate to your company. So I don't think it's going to replace data scientists. It may on the lower end somewhat. Like I said, if you're just doing a lot of reporting and visualizations, more basic stuff like that, then it's possible. But I don't think anyone really knows that yet. So it's uncertain. Is it important to learn time series? Yes, I didn't talk about this. For interviews, no. It's not really discussed a lot. I don't think I've ever had it been asked in an interview. Well, no, there was one interview where it was asked. I don't think you need to know it in detail. I mean, time series is something I knew really well as an atmospheric scientist, and at the moment, I haven't really had to use it a lot in my work. So I guess just review the basics, like what is ARIMA, how do you calculate a moving average. A lot of those basic techniques in time series actually are going to work pretty well most of the time. So I would just look into the basics if you're more curious. How do you think one can switch from SAS experience over 10 years to R Python? Are there some leverages? Oh, that's a tough question. I'd say the best way is to just download R or Python, and it sounds like you're just switching over to either one, and I would learn how to program in those languages. So there are a lot of great courses online that can help with this. They're free. I think you have to pay for it now, but there's stuff like Learn Python the Hard Way. There's a great website called dataquest.io that has a lot of great free courses on data science, and a lot of them are how to use Python. You're going to have to do some research on this, but that's a good way to learn. Personally, I learned Python just by reading the documentation and playing around with it during my PhD. That's how I learned it. Because the minute I started my PhD, I didn't know anything about Python except what it was used for. But by the time I was done with my PhD, I knew it pretty well. So that's what I would recommend to you. Which open source projects on GitHub do I contribute to get hands-on with data science? If you want to contribute to open source projects, I would say look for stuff that's in either Python or R. I think that's a good place to start. There are a lot of open source projects there. I'd look at the documentation of those projects and see kind of who is in charge of the pull requests for those projects, and then try to get in touch with them and see how you can help. There's always help necessary in open source projects, even things like documentation or just running a test on a new piece of code that's going to be included. So I would reach out to those people and see how you can help them because they really do need the help. What will data science be like in the next 10 years? I don't think people know exactly what it's going to be like in the next 10 years. My guess is that as computers become more powerful and are able to scale better, you may see some of these big data tools take over. If companies start wanting to use a lot of external data into their projects, I think that's going to be a very slow evolution, though. I also think there will be some increases in the algorithms that are developed for a lot of machine learning tools. I think XGBoost, for example, was a good breakthrough because gradient boosted trees up until that point were kind of computationally expensive. And so usually you would go for something simple like random forest, but then when XGBoost came out, that changed the paradigm. Or when something like a lot of the deep learning libraries that have been open source, such as TensorFlow from Google, I think has changed things a lot. I think you'll get these little spurts in innovation that will cause changes in data science. But the basics of data science, I think, will not change. You will still have to ask questions. You will still need to be able to pull data from databases. You will still need to develop models that serve your purpose and in some cases can be interpreted. So I don't think it will change from those basics very much. How to handle very large data in scikit-learn without using Hadoop. Will splitting the data into samples and then supplying it in the algorithm work fine? I would say scikit-learn actually does have some provisions, especially in linear models, where it can do out-of-core sampling. So you can generate an online model that uses stochastic gradient descent that will update with every training example it sees. And in that way, you could use infinitely large data sets. There's a library called Vulpal-Wabbit that was actually written for C++ that is great for this. It can handle any size data set you want. And because it's an online learner, it doesn't care. So that would be one way to do it without Hadoop. I would honestly say, though, as long as you get a representative sample of your really large data set, you can just develop the model locally with scikit-learn. And then later, if you need to export the data with something larger, you could use something like Spark, for example. Spark has a machine learning library called MLlib, and try that on your larger data set. So do most of the model tuning work beforehand on the small representative sample, and then see if it extrapolates to the larger sample. I think that'd be a good way to go. I'm a working professional. I've been in teaching for 6 years. I want to become a data scientist. What should I do? I'd say that depends on your background. If you have a strong background in, say, mathematics or statistics or programming, it's going to be a bit of an easier transition for you. If you don't, then I think it's going to take more work. I would say what's most important is to learn the concepts that I've been talking about, start networking at data science meetups so you can learn more things, and also developing your own pet projects so that you get more experience in actually doing data science. What are the most important packages in R used for data science? Well, the thing is, I used to use R. I don't anymore. I found Python is more helpful for most of my work, so I completely switched over to Python. Some of the important packages in R are things like there's basically any package that's been invented by Hadley Wickham is amazing. He's done a lot of great work for the R community. So there are things like dplyr, which are kind of like pandas in a way for manipulating data frames in an efficient manner that's expressive. If you're going to do it machine learning, unfortunately in R, machine learning isn't really bundled into one library. It's in a bunch of separate libraries, some of which are really weird names. There's like a gradient boosted machine library called GBM. XGBoost, for example, has both Python and R interface. So if you want to do machine learning with XGBoost, you're good in R anyway. The GLMNet library in R is actually very good, and there are some people trying to come out with a Python equivalent. I don't know if it's up to R yet, but it's very good. So for linear models, it's great. Someone having around 6+ years of knowledge of Python and can work on libraries with NumPy. How to apply for jobs? I would focus on your Python experience, but I would also say that you're going to probably have to fill in the gaps, such as, do you understand machine learning? Do you understand how to query databases? Do you understand how to work with data and merge it together? If you have a lot of knowledge of Python, you'll probably be able to learn that faster than other aspects. So I would say really emphasize your Python background, but also you're probably going to need to learn a few more things before you apply for jobs. If people want to leave, that's fine, but I'm happy to stay here and just keep reading questions because I just want to help everyone. So it's now 12:30, so if you want to leave, that's fine. I totally understand. I'm just going to keep reading questions that I've been given from Vishal in the meantime. That's okay with everyone. Which master's degree should be selected? For example, a master's in data science, a master's in applied statistics, or a master's in business analytics? Well, here's the thing. In the United States, a lot of these master's degree programs, they can get you a good start, but it's really, really difficult to teach everything that a data scientist needs to know in one master's degree program. And the other thing I've noticed is that a lot of these master's degree programs sometimes will result in jobs, but their track record isn't the best. So there's a program in the United States called Insight, which only accepts PhDs. Their track record is very, very good. It's like a postdoc 7-week boot camp. And almost everybody in that program gets a job. But for the master's programs, some of them are a bit of a cash cow, I think, for the universities. They're kind of trying to jump on this data science demand and trying to fill it. But if you really want to go the master's degree route, I would probably go with the MS in just data science. Because applied statistics or business analytics, unless you would rather do those things, aren't as direct of a path. I would just pick the one that says data science. Next question. Is Cloudera data science certification valuable enough to get an interview? That depends. I think some companies might like it, but I haven't noticed certifications being something that companies value. What companies really value is experience and a proven, demonstrable ability to do data science. So it won't hurt you, but I think that that may not be enough. I mean, I'm not saying don't apply. Go ahead and try it. But if you're not getting responses back, I'd say that maybe the certificate isn't enough for you to get jobs at some of these companies. For some companies, it may be enough, but it just depends. The market's very variable sometimes. I have just started with Coursera Andrew Ng's course. Is it necessary to practice math and get well understanding of it before that? Also, can I start directly with Kaggle while learning from Coursera? I would say if you can understand the math in Andrew Ng's course, because the math isn't that bad. If you just know basic calculus and linear algebra, you should be good to go. It's more important to understand, I think, the concepts behind how machine learning works and what it is at first. So it just depends on your math background. I don't know how your math background is. If you're coming from a background that has very little math, then you probably should take a refresher on linear algebra or differential calculus. There's some great courses on Khan Academy that are available that I'm sure would be a great help to you. Kaggle, yeah, I think you could start with some of the introductory competitions. They have some intro competitions that aren't for money, that are just for learning. There's one about Titanic. I think it's still there. It's been there forever. And you can start practicing some of these algorithms that Andrew Ng's talking about in the course. So learn about an algorithm and then look up how to implement that algorithm in Python or R, and then practice it out on the Titanic dataset. See how it works. So I think you can do that, sure. How much time should I devote in machine learning algorithms? Since in real time, we have to just apply the algos inbuilt into the library. So how important is it to learn the how part of the algorithm? This has been kind of controversial because some people feel that there's some introductory data scientists that just know how to apply the algorithm but don't really understand how it works. It depends on the difficulty of the problem you're having to deal with. So if the business is going to be happy for just a marginal improvement over the status quo that seems to be working based on your training and testing, and you go live and you test the model and it seems to have decent performance, you could probably get away with it, but I think in the long run it's going to hurt you because you're not going to understand how the algorithm's actually working. If you don't understand the algorithm's actually working, you're not going to know which situations it's best to apply it in. You're not going to know what underlying distributions or the kind of data that you have access to it's going to be a good fit for, and ultimately you're not going to get as good of results. So I think you need to take some time to understand how these algorithms work, because if you don't understand how they work and you have this lack of knowledge, you could get burned. So I would caution you that while you're implementing these algorithms, take some time to understand what they're doing. Having basic learning of machine learning statistics and very basic syntax knowledge of R or Python so I can start building a pet project. But what shall I do when I get stuck on a typical problem never heard before? Like I want to do a Kaggle problem, give me some credit. Well, you're going to get stuck on problems you've never heard before if I'm understanding the question all the time. This is part of data science. One thing that's a great test of a data scientist is if they don't know how to do something, they can figure out how to do it. This is going to happen a lot. It's happened a lot to me. It's happened a lot to a lot of data scientists. This is a very new field. Sometimes the solution is not easy. So you're going to have to research. You're going to have to test. And in the process, you're going to learn a lot of things. So I would say just try building something. Get started. When you don't know how to solve a question, research it. And you'll be able to find out the answer, and you'll become much better ultimately as a data scientist. The best blogs are staying updated with the latest in data science. I actually have some links to this on my website. My favorite is called DataTow. It's kind of like Hacker News, but it's curated more towards data science. So if you want to see a new paper that came out, or if there's a new library or version of library, or somebody's discussing a machine learning algorithm that they're applying to an interesting data set, this is the best place to go. You can find a link to it on my website. There's also Nate Silver's website, 538. Although he doesn't do traditional data science, he applies data in very interesting ways. I think learning how he communicates about the problems he's dealing with is extremely valuable. And I just think what he does is very interesting. And he's good at what he does. So I think it's a good place to read as well. Hi, I want to change careers. I already have a certification from a credible institution in my country, and I completed a couple of online courses. However, most job ads say they require X numbers of years of experience for a data science position. Any tips on how to get an interview if I don't have the experience? Okay, so here's the thing. That's where the pet projects can help. So if the position says you need at least 2 to 5 years of experience, it's going to be difficult for you to get that job. But if the amount of experience required is a pretty low number, like maybe 1 to 2 years, then you might have a shot. So in that case, again, I would do a pet project, show your work, demonstrate you know what you're doing. It depends, I think also, I guess you're not in school. It says you want to change careers. I did an internship when I was doing my PhD. So I don't know exactly how the internship process would work if you want to change careers. What I would do if I were you is talk to someone at the company that you know that maybe is on the data science team of a company you're just working in, explain your situation to them, and see what advice they give you. But this would be my advice, is just work on pet projects and try to develop your experience. I am a data center admin and know little Python. How should I start towards the data science path? Well, if you're a data center admin, that probably means you know a lot about accessing and working with databases, which is very, very valuable. But I think you're going to need to know how to utilize a language that was developed for analytics and data science. So if you know very little Python, that's okay. The good thing about Python, I think, is it's a language that's pretty easy to learn relatively compared to other languages. Like C++, I think, is much more difficult to learn than Python because Python is interactive. It doesn't really care as much about types. The documentation online is very good. There are a lot of helpful people in the community. The way the code's written is, I think it's easier to read compared to a lot of other programming languages. So I would just practice. Okay. I'm just reading something right now. Okay, so what's going to go on now is there are a few other questions here, but okay, I'm going to answer, I think, 4 more questions, and then I think we're going to wrap up. And then Vishal can email me some later. So, is it better to learn both R and Python instead of specializing on only one? I actually used to do this myself. I learned both R and Python because I wasn't sure which direction things were going, when I would need to know one or the other. I used to recommend learn both, but if you try to learn both, it's going to take you more time because R does not have an easy learning curve. I think R actually is a little more finicky than Python. It takes more time to learn because it does things very differently than a lot of other programming languages. So I really think, at least for your first job, you should really just specialize on one. Get really good at one. Because then if you're just mediocre at both, you might not be good enough to get past that initial stage. So just focus on one for now, and I would actually recommend Python. How to see myself in 2 to 3 years? What are my goals? Well, I just starting a new job, so I would like to stay there for a while and see what I can do. I think it's going to be really interesting to, for example, build a brand new recommender system for all of these news websites that has never been developed before. And I would be very proud of myself if I can be a part of that. And eventually, I would like to just develop my skill set more, work with different kinds of data, develop different kinds of projects, and I think I really want to see what I can get out of my work at tronc, because I think there are a lot of possibilities that are very interesting. Eventually, though, I think by the end of my career, I'd like to move up to being a head of a team myself, and maybe even work in the executive suite, maybe as something like a chief data officer. Those are positions that have started to come up, and in that case, I would focus more on the business strategy of a company has a question it needs to solve with data. How can we go about doing that, and how does that fit in with the company's strategy? I think that would be very, very interesting work after I've had more experience. What do I think about potential of robotic process automation? I guess I don't know the context in which this question is being asked. If it's being asked in terms of, say, a lot of factory jobs, for example, are being automated. I saw a report just last week about a Chinese factory that replaced all of their human workers with robots, and the robots were actually functioning more efficiently. I think it's something that people need to think about. So, for example, self-driving trucks, I think are going to be a reality a lot sooner than most people think. I don't think it's going to take 30 years. I think it could probably be done in 10 to 15. I don't know for sure. This is just my thought. And the most common job in a lot of America is truck driver. And so we're going to have to figure out what to do. I think we're going to have to retrain these people for a new job. And this has happened before where people have been replaced by a machine. They've had to transition to a new role. I think it can be done, but it's going to be something that's going to require a lot of thought and a lot of consideration and care. Can I briefly explain H2O and how one can use it? I'm familiar with what H2O is. I was actually thinking of using it for a project I was working on at my previous company because I needed to use a special distribution that's really good with insurance data. And it was only available at the time in very few libraries, one of which happened to be H2O. And I was going to use it, but then a new one came out for XGBoost that didn't require me to need to use it anymore. So I didn't end up using it. It's an open source tool. It's available in both Python and R. I think similar to any other open source tool, I'd read the documentation, look at the examples, and then just practice using it. But I don't have very much experience with it. Can you mention some open source visualization tools that I can use to start with visualization? Sure. It depends what kind of visualization you want to do. If you want to do just 2D visualization of data, such as graphs and charts and that sort of thing, R and Python are going to have a lot of libraries that can do that. R, there's a great one called ggplot2 that was made by Hadley Wickham. It's very good. There's another one for Python that's based on matplotlib called Seaborn that I mentioned earlier in my talk. That's also very good. And there are a lot of them out there. If you want interactive data visualization, though, you're going to have to leave Python temporarily and go for what's called d3.js. It's a JavaScript library parsed by Mike Bostock. It's the best interactive visualization library that there is out there. So if you want to build interactive visualization where people click on things and the visualization changes, that's definitely the one to start with. There's a book I recommended on my website that has an introduction to D3.js and kind of explains how to use it. It's not easy to use, in my opinion, and there's also a great gallery that Mike Bostock hosted that also has access to example templates that you could use for your own purposes. How do you approach a particular data science problem? Well, oh, by the way, for everyone listening, we are going to be uploading this recorded session onto the Hackerearth YouTube channel. So if you missed something or you want to see this again, it will be available in the future. When I approach a particular data science problem, the first thing I do is I figure out, first of all, what question actually needs to be answered or what problem needs to be solved. Because that's really an important process. If you start going down the wrong path, a lot of your work's probably going to end up being wasted. So really understanding what the true goal is very important. Because I think some people just say, our goal is to make a very accurate model. Well, accurate at what? How is it going to be incorporated into our system? What is it going to end up doing? How does it add value to the company? These are very important questions that need to be answered first. Then once you've figured that out, I'd say the best thing to do is understand how the data that you have internally was collected. So try to become very good friends with whoever was in charge of that data capture process. That might be your data engineer, that might be your database administrator, whoever. You need to really understand that because that's important. Because if you're making a model based on this data and your understanding or assumptions about how the data was collected is wrong, then your model is not going to work. And I've actually run into this problem myself. So you need to be careful about that. Once you've got that all figured out, then you can start strategizing which external data sets you want to include, maybe a rough modeling strategy of what kind of models might work for this type of problem, how you would test it, how you would prove it was working, how you would update the model, and then go from there. It's a very iterative process. You may have to go back all the way to step one at some point. Okay, so I think we're good on questions for now. So thank you to everyone that came. I hope you found this useful. And I want to thank Vishal and Manish again for hosting me. I was very happy to be here. And good luck to all of you. Thank you very much.